Welcome and thank you for always joining our discussions. We are presenting K.c.s.e 2018 Paper 1 question number 24, a question on differentiation and its applications. And the question we have reads, the equation of a curve is given as y is equal to a third x cubed minus 4x plus 5. Determine part A, the value of y when x is 3. So when x is 3, the value of y would be equal to, we are going to substitute the value of x in the equation. That is, we are going to have a third x cubed. Remember, the value of x is 3, but cubed, minus 4 into the value of x is 3 plus 5. This one is going to give us 3 cubed is 27 times a third will give us 9, minus 4 times 3 is 12, plus 5, and this one is going to give us 9 plus 5, which is 14. 14 minus 12, you get the value of y as 2. That has already been done. We move to part B of the question. And in part B, we are supposed to find the gradient of the curve at x is equals to 3. And the first thing we are going to do, since we have the function in the form of y is equals to a third x cubed minus 4x plus 5. For us to be able to find the gradient, we must first get the gradient function of the curve by differentiating the given function, that is dy over dx. And the dy over dx is going to be, this power is going to multiply down here such that we are going to have 3 times a third x cubed. Then we less 1 from the power after we have multiplied that. 3 and 3 will cancel such that we are going to have x cubed minus 1, which will give us x squared. Then minus, remember we have 4x, and for us to differentiate 4x, this is the same as 4x power 1. We multiply by 1 here, then we less 1 from the power such that we are going to have 1 times 4, which is going to be 4x power 0. And x power 0 is 1, 1 times 4 is 4, and therefore the gradient function is going to be x squared minus 4. Once we have done that, we can now move and get the gradient at x is equals to 3. So we can say at x is equals to 3, then the gradient is going to be equal to, the gradient function is x squared minus 4, and therefore we are going to take x, then we square minus 4, and this one is going to give us 3 squared will be 9, 9 minus 4, this one will give us a gradient of 5. That is part B already done. Then we go to C, and in part C, we are being told to determine the turning points of the curve and their nature. How do we determine the turning points? We know for a fact that at turning point, the dy over dx of any function will always be equal to 0. So what we are going to do, we are going to pick the dy over dx and equate it to 0 so that we can be able to get the values of x, which we are going to use to get the values of y. The dy over dx is x squared minus 4, and this one will be equated to 0. That means if we move 4 to the other side, x squared is going to be equal to 4. And if you want to get the value of x, we are going to take the square root on both sides, and therefore x will be equal to the square root of 4, which will be equal to plus or minus 2. That means the value of x can either be positive 2 or also negative 2. Once we have gotten that, we are simply going to say when x is positive 2, then the value of y is going to be equal to, the value of y will be equal to a third. Remember, we are going to substitute this in the main function. A third into x, which is 2. 2 is cubed, minus 4 times x, which is 2, and of course plus 5. And the value of y in this case is going to be a third negative, or simply negative a third. Once we have done that, or once we have gotten the value of y, then the point we are talking about here, the first point is going to be 2, then negative a third. Then we go and again get the value of y when x is equals to negative 2. Then y will be equal to a third into x, which is negative 2, but this one is cubed, minus 4 into the value of x, which is negative 2, plus finally 5, and this one is going to give us 10 and a third. Once we have gotten that, we can now again write this point down, and the point we have is negative 2, then we have 10 and a third. These are the two stationary points so far. We are going to move forward and determine the nature of these stationary points. What are we going to do? I'm going to pick the first point, which is 2 and negative a third, then determine the nature of this point. We are going to use the x coordinate. We place the value of x, or the x coordinate, at the center. Then we pick the step behind. We also take another step forward, which will be at 3. This is x. Then we need the dy over dx here. After that, we need the diagram. Now, remember the dy over dx from our question is x squared minus 4. So when x is 1, then we are going to have the dy over dx being 1 squared, which is 1 minus 4, which will give us negative 3. When x is 2, the dy over dx will be 0, because 2 squared is 4 minus 4 is 0. And when x is 3, we are going to have 3 squared, which is 9 minus 4, giving us 5. And you can see the gradient is simply moving from negative through 0 to positive, meaning when the gradient changes from negative through 0 to positive, then this particular point is a minimum stationary point. So 2 negative a third is a minimum stationary point. Once we have done that, we can now pick this other point, which is negative 2, 10 and a third, then determine the nature of this point. Again, what we usually do is to pick the value of x, or the x coordinate, which is negative 2. Then take one step behind, we are going to land at negative 3. Another step forward, we are going to land at negative 1. After doing that, this gives us x. Then of course we need the dy over dx. After that, we need the diagram. So when x is negative 3, we are going to substitute in the dy over dx. We are going to have 9 minus 4, which is 5. At x is negative 2, negative 2 squared is 4 minus 4, which is 0. And when x is negative 1, we are going to have negative 1 squared, which is 1 minus 4, giving us negative 3. So you realize the gradient is changing from positive through 0 to negative, meaning that this particular point is a maximum stationary point, and therefore negative 2, 10 and a third is a maximum. So we simply mean a maximum stationary point. That brings us to the end of this question. Remember, we have 3 types of stationary points. That is a minimum stationary point, maximum stationary point, and a point of inflection. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome. For support, online classes, or questions relating to this particular topic, feel free to contact us through 0701 686 283. Thank you and welcome.